The typical way we start this Waves and Sound unit is with the Slinky Lab. If we didn't have a pandemic going on, it's almost a rite of passage that everyone that takes grade 11 physics at SJM does the Slinky Lab. It's not even a hard lab, in a way it's a fun lab. We literally give you a crazy long Slinky and send you out into the hallway to experiment, to play with the Slinky, hopefully not tangle the Slinky, and get some intro knowledge to how waves and eventually how sound behaves. Unfortunately, we can't do labs and everybody's at home, so we're going to do this one with a simulation. The link to the simulation is here. Over and over again, you'll see we use these PhET simulations. PhET is a university program. I think it's out of Colorado in the States. Basically, they made a group project between computer programming students and physics students. And over the course of the years, these group projects, kids having to design things, churned out some really, really good simulations. Sometimes we use them for circuits. Today we'll use them for this one, and we'll use them. You'll see them again before you're done physics with us at SJM. Watch that little video clip. We teamed up, Mr. Zare and I do some things together, so I'm borrowing his video that he made on how to actually work the simulation. The lab isn't too big. You are going to hand it in. It will be a quick mark. You should be able to get it done in a day. I just want to point out some of the little things that had we been in class face to face, we could talk about it. So follow the instructions in here. But the first question is about the amplitude of a pulse. Amplitude, you may have heard it in math class. If we're talking about waves, say I've got a wave that looks like this. It's hard to get nice shaped waves in the lab unless you use that pulse option. But let's say we've got a pulse, a burst of energy traveling down a Slinky that looks like that. Maybe it's moving to the right, so it's headed that way. Eventually there's questions about the speed, but we'll come back to that. When we talk about the amplitude of a wave, an amplitude is how tall the wave is from that sort of the flat part of the Slinky to the very, very top. Or if you created a wave by shaking it the other way, then the amplitude would be from that sort of resting position when there's no wave all the way down to the very, very bottom. That's what amplitude is. It's basically the maximum height of the wave measured from that resting spot. Sorry, tickling my throat. Basically, you're going to send a pulse down a string or the Slinky or whatever that PhET simulation, whatever you want to call that thing, and you're going to comment on, as that pulse is traveling, what happens to its amplitude. Then change the tension by making the tension larger. Tell me about the amplitude again, and also tell me about the speed. How does the speed with higher tension compare to kind of what you did originally? You don't have to do anything fancy with the meter stick and the stopwatch, just kind of eyeball. Does it seem to be going faster or slower than it did before? Then we're going to make the opposite change. We're going to loosen the Slinky, loosen the tension, decrease the tension, and make the same two observations. What happened to that amplitude thing? What happened to the speed thing? And again, no meter sticks involved, just like up here you compare to the original wave. For this one, when you loosen it, how do speed and amplitude compare to the original pulse? That's part one. Just change the tension a couple times, keep track of speed and amplitude. Part two, you're going to reflect the pulse off different ends. So send a pulse down the Slinky, have it reflect off a fixed end, and tell me what happens. What does it look like after the reflection compared to before the reflection? Then switch it to a free end and do the exact same thing. What happens to the pulse after hitting a free end? Compare before the reflection to after the reflection. And then that's it really for the lab. Just write a couple sentences to wrap it up. Tell me, what can you do to change the speed of your wave? You should have figured that out. Tell me, does amplitude seem to connect the speed of the wave? And there's a third question I've added that didn't make the cut here. What did dampening do? I don't know if it's damping or dampening. What did dampening seem to do to the wave. That's it for your lab. It's really just qualitative. Yeah, no numbers. You can just sort of describe faster, slower, bigger, smaller, words like that. Just to learn a little bit about waves. Email if anything's bugging you.